In examples 3 and 4, we want to verify each one of these trigonometric identities. At first glance, for example 3, it looks like the left side is just about as complicated as the right side. Arbitrarily, I'm just going to choose this right side to work with. One thing we could start with is we could just try to change everything into sines and cosines. That's a great thing to do if you're kind of at a loss. So the cosecant squared is going to be 1 over the sine squared. And then the cotangent is going to be cosine squared over sine squared. You'll notice that we can actually add these fractions together. So this will be 1 minus the cosine squared over the sine squared. And then I can change this 1 minus cosine squared into sine squared. And that's based off of the trigonometric identity using the Pythagorean theorem. So if I were to only subtract cosine squared from each side, I'd have sine squared equals 1 minus cosine squared. So I am allowed to change this out in the numerator for sine squared, and then I've got sine squared in the bottom. That's just one. So one of the hardest things with these trigonometric identities is that if you try to simplify one side, sometimes that does work, but take a look at this side. It's pretty complicated as well. So what I like to do in this case is I'll try to work with the left-hand side, knowing that I'm only supposed to work with one side at a time. So I do this lightly in pencil. And if I look at the left-hand side, I've got the sine of alpha, and then I could change the cosecant into 1 over the sine. And then here I've got cosine of alpha over secant, which I could change into 1 over the cosine. If I take sine of alpha and simplify this entire fraction right here, I'm going to wind up with sine squared. You can take the numerator and just multiply by the reciprocal of the denominator, so you're going to have sine squared. This one's going to work the same way. We're going to end up with cosine squared. That's just one. Now what we have is we have a way to get back to the left-hand side. What you do is you can take a look at each step that we did on the left-hand side and write that down in reverse order here. So we've got 1 is equal to the sine squared plus the cosine squared. So that's this step. The next step is to rewrite this as the sine of alpha over 1 over the sine of alpha. These two are equivalent. We're allowed to write that. And we've got the cosine of alpha over 1 over the cosine of alpha. I have to move this up a little bit. Now we can change this into the sine of alpha over the cosecant of alpha. And then we've got the cosine of alpha over the secant of alpha. So now this is the exact same thing that we started with. And I like to write this down just to verify that I have what I need. So all I'm doing is just taking this left-hand side and just writing that down here. And I've got to have the exact same thing. And now that trigonometric identity is verified. To make this look like you did all the work on your own, what you can do is you can just erase all of this stuff over here. And if you erase really well and fool someone into thinking that you've only done one side of the equation, then it totally looks as if you've just done the one side. So I know this isn't totally erased, but try to do your best job to erase all that, and then you can see it kind of looks like here that you've done all the work on one side of the equation only. For example 4, let me reset the viewing window here for you. So for example 4, we're going to work with this. Sine of alpha plus cosine of alpha squared, that's quantity squared, is equal to 2 plus the secant times the cosecant over the secant times the cosecant. So to begin this one, I think this right-hand side is a little more complicated myself, but we'll see. And if you start with this side and don't figure it out, you can work with the left side and try to figure it out from there. and maybe you'll find a link. You just have to work with one side on its own. So what I'm going to do here is I'm going to write this as 2 over the secant of alpha, the cosecant of alpha, plus secant alpha cosecant alpha over secant alpha cosecant alpha, which is just 1. Then I'm going to rewrite this using my sine and cosine. Oops, let's put this right in the middle. That's just the cosine here, and then the cosecant's reciprocal is the sine. So there's your 1 over the sine. Now what I'm going to do is I'm going to take this and multiply the numerator by the reciprocal of 1 over the cosine, which is the cosine times the sine. I still have that plus 1 hanging out over there. At this point, I'm kind of at a stopping point. So what I'm going to do is I'm going to try that little method, and I'm going to try to square this whole thing. You can write this out, and you're going to get sine squared plus cosine squared plus 2 sine of A cosine of A. That's what would happen if you'd FOIL this whole thing out. Notice how we've got a 2 sine A cosine A, and this is a 2 cosine A sine A, really the same term. And then here we've just got sine and cosine, so this is 1 plus 2 times the cosine of A, the sine of A. So now we have a link between the left side and the right side. All we need to do then is we need to write down those steps in reverse order. So I'm going to change this 1 into a sine squared. So I'll have 2 cosine of A sine of A plus sine squared of A plus cosine squared of A. Now this whole thing can be factored into sine of A plus cosine of A quantity squared. That is an allowable move if you factor this. If you're having trouble with this, try to let maybe sine squared or sine equal x, and you've got x squared, and maybe let cosine equal y or something like that, and then you've got y squared, and then you've got 2xy here. And you'll notice that you can factor it into this form. Now the left side looks just like the right side. So we've got the sine of A plus the cosine of A squared. That's exactly the same. So this is verified. Yet again, we're really only supposed to work with the right-hand side or the left-hand side, just one side on its own. So what we're going to do is just try to erase this to the best of our ability. And if we do a good job erasing, then it kind of looks like we just worked on the right-hand side and then got that to look like the left-hand side.